I'm Henry Ford III. I'm the marketing manager for Ford Performance. We are here at the Dearborn Development Center, and you're going to see a couple different videos from several of the engineers on the new Shelby GT350 Mustang. We're really excited about this product. It's the most capable Mustang we've ever built, and we know you're going to love it just as much as we do.
Hi, I'm Lindsay. We're at the Ford Performance Dearborn Development Center, and today we'll be getting an in-depth look at the latest creation from Ford Performance, the new Shelby GT350. This is a car built for the same purpose as Carroll Shelby's original in 1965, to be ultra-quick on road racing tracks. The team of engineers who worked on this car took on some very aggressive goals for power output, handling, and aerodynamic balance. And today, we'll find out how they did it. The heart of the new Shelby GT350 is the engine, the most powerful, naturally aspirated production engine Ford has ever produced. It's a 5.2-liter V8 that's based on the 5.0 engine, but pretty much everything inside is different, modified and tuned to produce awesome power that's also remarkably drivable. And it makes that delicious, spine-tingling sound. Eric Ladner, Ford Performance engineer, is here to tell us a lot more about it. We're here with Eric Ladner, Ford Performance engineer. Now, Eric, the heart of the GT350 most definitely is that 5.2-liter flat-plane crank V8. So why don't you tell us a little bit about that engine?
Okay. Well, the 5.2 is an all-new engine for Ford. It's the highest performance, highest power V8 naturally aspirated engine we've ever produced for a production vehicle. It's got 526 horsepower at 7,500 RPM, revs all the way up to 8,250 RPM to provide usable power beyond that maximum power speed, and peak torque at 4,750 RPM of 429 foot-pounds. It's really an engine tuned and designed for the track. So we have a very high and wide, broad torque curve.
Now that flat plane crank, how does that differ from your conventional cross plane crank?
So the flat plane crank is one of the key features. It's one of the main things that makes the engine unique and special. So the flat plane crank, it's called a flat plane crank because the crank pins are arranged in a single plane. So you can see here it would be a horizontal plane where they're flat this way. In a cross plane crankshaft, you would have one pin up and one pin down in this configuration. So what that really means to the engine is it sets up a different firing order. We get even space firing, even space pulses, and we separate those exhaust pulses. It's for better breathing and results in better performance of the engine. One of the other key features of a flat plane crankshaft is with its balance, it allows us to use smaller counterweights, which in turn results in lower weight and lower rotational inertia. So it's lighter weight than a cross plane crankshaft, and it also is lower inertia, which helps it rev faster. And this engine does, rev high and fast. In addition to that, we actually gun drilled the center of the crankshaft as well to remove additional weight, again, unnecessary weight that wasn't needed. That's through these main pins. This also allows bay-to-bay breathing. So as the pistons move up and down, it allows it to push air back and forth from one bay to the other, and that reduces parasitic losses and increases performance.
So what's the big thing that drivers will notice?
Probably the first thing they'll notice is the sound, the unique sound, right? So the firing order with the flat plane crankshaft combined with our exhaust manifolds and the vehicle exhaust system provides a very, very unique sound. So attached to the flat plane crankshaft, we have an all-new piston and rod assembly. So this is made up of basically all new parts. We have a forged aluminum piston that's built for speed and power. In that we have low tension rings which reduce friction, and those are attached to a forged steel connecting rod with a fracture split cap. And then you have the piston dome here, which you can see has cutouts for the valve pockets and a pent roof here, which gives us a 12-to-1 compression ratio.
Okay, so what's the benefit that we'll see from that?
So the forged components really add strength. The lightweight piston, again, is kind of critical to engine speed. And then we have the small skirts here, which actually reduce contact area and reduce friction, which enhances performance.
So Eric, what don't you tell us about the high-performance cylinder head that we're looking at here?
Okay, so for the 5.2 liter, we have all new cylinder heads, all new machining and casting tooling. The reason we did all new heads is because with the larger bore we have for the 5.2 liter, to fully take advantage of that, we needed to increase the valve size. So our valves in the heads are larger than you'd find in the 5 liter, for example. But to really maximize them, we had to move them out. So the valve positions and sizes are completely new and unique. The whole valve train layout is. The cylinder heads themselves are CNC machined. So we've CNC machined the chambers and the ports. The ports have been optimized using CFD, computational fluid dynamics, for maximum flow. And then while we were CNC machining the heads, we've, with our focus on weight, we actually machined some additional unnecessary material off as added operations to reduce weight.
Now, Eric, it looks like you've taken an innovative approach to the oil pan. Why don't you tell us what's special about this?
Okay, yeah, so we knew for a track vehicle that brakes and handles as well as the GT350 does, we needed to design an oil pan handling system that was up to the task. So to us, for that handling and for the engine speed, we knew we needed increased oil capacity over what we would normally have. So to achieve that and minimize weight, which we took a very aggressive approach to weight reduction on every part throughout the engine. This is one that afforded a great opportunity for us while doing it in a composite. So we actually integrated the pan, the baffle, the pickup tube, and the windage tray, as well as the gasket, all into one single composite assembly. And the result is an oil pan that performs. It has higher oil capacity than we'd have in a 5 liter, for example, like 2 extra quarts, all the while being lighter as a system, about 20% lighter than what you'd find in a 5 liter. So you can see it's really quite a lightweight assembly.
Right. So the breathability of the engine is important with the 5.2 V8. So why don't you tell us about that?
Okay, yeah, so to create 526 horsepower, it really takes a lot of airflow. And to maximize performance, you want to minimize all the restrictions upstream of the engine. So to do that, we've utilized this large open air element air filter system.
So why are customers going to really like this new 5.2 liter V8?
Well, it's a very high performance engine designed and made for the track, which is what the GT350 is designed for. So it's an engine well suited to that vehicle. So what we did was we really focused on performance, high power, high torque, a very broad torque curve, maximum engine speed, and lightweight. Those were the key features that we focused on a daily basis and went into every decision we made on every part we designed. And it's really an engine tuned and designed for the track.
The GT350's powertrain, from the engine on back, has to transfer all that power to the wheels and the road, and do it as efficiently as possible. Also, the entire powertrain has to withstand the high heat and high stress of track use. Here too, the GT350 has had some very special attention. And for more about those aspects, Brian Zorman of Ford Performance is the man. Okay, we're here with Brian Zorman, powertrain engineer from Ford Performance. So Brian, why don't you tell us a little bit about what you did on the GT350?
Yes, I am from the Performance Division for the powertrain group. Worked on everything from pretty much the flywheel and clutch all the way back to the rear differential on the vehicle. What you have here is the dual mass flywheel and clutch assembly, which is our brand new design for the GT350 to go in hand with the transmission and everything else. The first part we're looking at, let me take it apart here, is the dual mass flywheel. It is a non-damp system which works with the dual mass clutch. And here you have the disc, the clutch for the dual clutch system setup. And combining these two items together, we have a very low inertia system in the vehicle for the customer to get a very quick response for RPM to hit the red line as fast as possible. Because nothing is better than having a quick spinning system to reach the max RPM of the vehicle on the track.
The engine's putting out quite a bit of power, so cooling is going to be a big part of the system for the 350, isn't that correct?
Absolutely. You know, high RPM, high horsepower for a naturally aspirated engine, high torque on the track produces a lot of heat. And the only way to get rid of and dissipate the heat out of the system is having miniature coolers, just like a radiator on a car. We have little radiator coolers for our engine, oil, our transmission, and our rear axle. And what you see here are the two coolers on the front of the vehicle. One is for the transmission, and the other one is for the engine oil cooler. So the faster you can get rid of the heat in the system, the better the performance of the vehicle will be on the track. The faster you go, the better they work.
So it's important that both the front and rear components stay cool, right? So what do we have here?
What you're looking at here is the rear differential cooler and pump on our GT350. It's located in the rear of the vehicle now. Instead of having it mounted in the front of the vehicle like our past GT500, the GT350 has it mounted in the rear. It saves on extra weight of coolant and routing of hoses all the way to the front vehicle and back. Putting it in the rear, we save weight. That's the biggest thing for the race track. The way we cool it is mounted in the rear with a special diffuser that pushes air up underneath the vehicle through the radiator and out the back of the rear fascia. So putting it all in the rear, we save the weight. Don't have to worry about any debris getting caught in the radiator in the front, and we are able to keep the axle and differential cool when needed on the track.
Okay, so with a more powerful engine, what did you have to do to the powertrain to beef it up a little bit?
What we ended up doing was taking a look at what we already were starting with for the current Mustang, and we reevaluated our half shafts and our wheel bearings and differential. And the first part was the half shaft. We need to have a stronger half shaft for the higher horsepower and torque in our engine. And we came up with a larger half shaft in overall for our vehicle. A larger bar shaft for more torque capability to transmit the torque to the wheels. And then also improved the outboard and inboard joints of the vehicle also for a more robust system. With the half shaft and how much larger this has become, we worked on incorporating it with the current wheel bearing assembly for the GT350. And with the wheel bearing being a little bit different due to our brake system, we had to minor tweaks and changes we did to make the half shaft integrate with the wheel bearing and brake system on our vehicle versus base Mustang.
So what's different with the rear diff for the 350?
We ended up having a unique internal differential gear set with a bias ratio, which helps transfer the most torque to the wheel that has the best grip on the track. With these three components here, we wanted to make sure that the vehicle was strong as possible. That's the main part of this, is to make the most robust parts possible for our customer.
Okay, now we're driving a new Shelby GT350. With all that power going to the road, it's generating tremendous dynamic forces, G-loads from cornering, acceleration, and braking. So, the chassis systems, suspension, steering, and brakes are also an essential part of the performance equation. In developing this car, every aspect, every component and system was analyzed, tested, and if necessary, modified or changed to reach performance targets. Here's Brent Clark of Ford Performance to talk about what's been done with the chassis systems. I'm joined by Brent Clark from Ford Performance. Hi Brent, why don't you tell us what you do at Ford and what you did on the Shelby GT350?
Oh, good morning, Lindsay. So I'm responsible for vehicle dynamics on the new GT350, which basically means that I lead the team that does all the development for the ride, steering, and handling of the vehicle.
So why don't you tell us what makes it so special?
Well, we had a great foundation to start with. We started with a very good body structure from the base Mustang, which is 28% stiffer with the new car. And from there, we pretty much kind of went through every system of the vehicle, trying to figure out how we could maximize the handling and overall performance of the car. Did some very significant suspension upgrades, lots of new parts there. Looking for every little bit of performance that we thought we could get from the base cars. Speaking of parts, we got some very critical parts for us here in front of us. With our new brake package, these are the most powerful brakes we've had on a production Mustang ever. These are 15.5-inch diameter rotors by 1.4 inches. They're a directional vane rotor, which means that they're just more efficient in the pumping. So you'd have a different rotor on the right-hand side versus the left-hand side of the car. The other thing that we've done here is we've got an aluminum hat that's on floating pins, and you can see this with this little pie piece. There's actually pins all the way around the aluminum part of the center hub that are cast into the iron rotor on the outboard side. And what that does, it helps reduce the heat transfer into the center section to keep the bearings nice and cool, so we don't have issues with those. It also helps us get some weight out of the components with the aluminum center. And the iron disc basically floats on these pins, so the thermal expansion keeps everything in alignment. You don't get any distortion there. The other big critical part of this package are these fantastic looking 6-piston brake calipers from Brembo that have integrated bridge. They're all a single piece of aluminum, which makes them extremely stiff. So we get very consistent and reliable pedal feel under braking, which is always a good thing. When you're going fast, you want to be able to stop.
Now, Brent, lightweighting is a big part of the GT350's story. So why don't you tell us about some of the lightweight components?
Absolutely. So we spent a lot of effort trying to get as much weight as we could out of the car. One of the areas that we did that was in the suspension. That allowed us to get some of the what we call unsprung mass out of the vehicle, which helps with the ride. It also helps with just overall vehicle performance in terms of acceleration, handling, all those things. Now, the great thing about this is that we were also able to not only get weight out of the car, but increase the stiffness. And when it comes to the suspension for the steering and handling, stiffness is very key. One of those components in particular is our front suspension knuckle. This is all new for the GT350. It allows us to incorporate our much larger front Brembo brakes, as well as providing that extra stiffness that we need for our performance objectives. One of the other things that also allowed us to do was modify the geometry to take advantage of the larger wheels and tires that we have on the car, so that we can maximize the handling as well as the steering feedback to the driver. We also get to take advantage of this type of design for the front wheel bearing, which again just adds more stiffness to these components. So we're saving weight and we're getting a performance advantage in the stiffness that helps both our steering and our handling for the GT350s. On the rear end of the car, we've got this unique aluminum lower control arm. Saves us a lot of weight, again, to improve our ride and handling performance. We had to make some modifications to this piece versus the base Mustang car, again, to get the optimal geometry that we were looking for.
Now, this is the first application of the MagneRide suspension, correct?
Yeah,
for Ford?
That's correct. And it has really provided us a lot of opportunities to deliver both a reasonable street ride as well as ultimate track performance with the new GT350. A typical strut and shock assembly, it's always that compromise between street performance and street ride versus what you would want on a racetrack, which clearly have different demands. And the new MagneRide system has really given us a lot of that flexibility. The way the system works, it actually has metallic particles in the fluid, and we can change the viscosity of that fluid simply by changing the current into the damper unit itself. So as we increase current, then the viscosity goes up, gives you more control for something like you may want on a racetrack. This not only affects the ride performance, but we can also tune it to help manage the vehicle roll, the vehicle pitch under braking and acceleration. So there's a whole host of things that it really helps us deliver in terms of the handling and ride performance of the new car.
Okay, so tell us about this carbon fiber wheel. I've never heard of a carbon fiber wheel.
Yes, it's very new to us. It's really a fantastic piece. It's very light, very strong. You can get a lot of advantages for both. Go ahead, you pick it up.
Let's see how, it's pretty light.
See, yeah, very light. It provides a lot of advantages to us from both a ride perspective, but also from a performance perspective, because not only is it saving just weight, but also the inertia when you're accelerating these wheels. We saved 50 pounds versus the aluminum wheels just by going to these carbon fiber units. And they've been extremely reliable, extremely robust for us. It's been a real great performance add to the car.
Okay, so with all these different systems, what does that mean to me as a driver?
Well, what it really comes down to is this new GT350 Mustang is a fantastic car, whether you're on the street or you're at the track. We have all the features there now that allow us to give you a car that if you just want to go drive to the grocery store in your new Shelby, you can do that, and you can be comfortable with it. But if you decide you just want to go have that track day on the weekend, you can go out there and rip it around the track and be fully confident that that car is going to deliver exactly what you're expecting.
Compared to any other aspect of the Shelby GT350's performance equation, aerodynamics is equally important. Everything has to work well together to produce great performance dynamics, and the aerodynamic capabilities are critical. Here too, the engineers took a no-compromise approach. Every place where air flows over, under, around, or through the car's body was examined, tested, and modified to get the great balance and the cooling optimization that they wanted. John Pfeiffer of Ford Performance is here to tell you about the GT350's aerodynamic modifications. We're here with John Pfeiffer, Ford Performance Engineer. Now, John, why don't you tell me what you and your team did in your role with the Shelby GT350?
I work in the aerodynamics team, and we make up body engineers, powertrain engineers, simulation modeling engineers, and I was the development engineer on this to lead the aero team. And what we did is we took the car from the initial concept drawings, starting from the Mustang GT, and evolve it into the GT350. And what we do is we literally touch hundreds of parts through computer modeling, CAD drafting. We go into the wind tunnel, we built a scale model, we built full-size prototypes, and then ultimately we had production cars that we would take to the racetrack to test for performance.
So why don't you tell us a little bit about the aerodynamics story here?
So the aerodynamics on this vehicle, we were very aggressive in trying to get the downforce that we needed so the car can be as fast as possible on the racetrack. We wanted it to be slippery to give it the top end pull as you're accelerating down the straightaway. And we also need to be able to cool all the systems on the car. We need to cool the engine, we need to cool the oil, we need to cool the transmission, the differential, and the brakes. So we looked at the air on how it hits the car, goes through the car, around the car, and out the back.
Now, speaking of the back, so why don't you tell us a little bit about the diffuser here?
So the diffuser is a very special part for us. The diffuser is set up by the aerodynamic parts in front of it. So the air comes underneath the car, goes across the belly pan. The belly pan sets the air up for the diffuser. And then what the diffuser does, it creates a negative pressure, so that as the air comes by, it sucks the car to the ground. What you're seeing here is the view from the underside. And as it sucks the car to the ground, some of the air goes up into these ducts, which feeds the rear differential cooler, which is behind it, and then exhausts out the rear fascia. The benefit of having this part on the car, drawing the car to the ground at high speeds, you gain stability, driver confidence, so you're going really fast through a turn, and the back end is planted, so you feel like you can go fast, and it usually helps you go faster. The downforce is very important. We need to get the grip on the front tires. So keeping the front end stable at speed, as well as giving that driver confidence, We developed for the R, this is the R splitter. The R splitter is a little bit larger than the non-R splitter, creates a little bit more downforce, and it sets the air up underneath for the belly pan for our downforce. So as the air comes under it, it feeds right into the belly pan, which creates that negative pressure in the front to give you more downforce. What's unique about splitters is that they create a positive pressure on the top and a negative pressure on the bottom. So it's, as well as sucking down, it's also pushing down. And what's important about this part is that it's very strong. We added this ribbing in here to reinforce the part, to prevent deflection and hold everything in space as the car drives down the road.
Obviously, managing airflow is important for the Shelby, so tell us about the underbody belly pan.
Okay. The underbody belly pan was one of the first parts that we developed for this car because it is the foundation for our front downforce. The splitter is in front of it. It would be right here. And what you're looking at from this point of view is kind of the business side of it. You're looking at the bottom side of the car, bottom up. The air is coming from the front. It's going under the car. It's coming across this surface. We want to keep it nice and flat to create that negative pressure, so it's sucking the car to the road. It's sucking the car to the road. And then we have these small features that are in the belly pan that make it a big difference for us. These small features, we have these kick-ups in the rear of the belly pan. This is right near where the transmission is. And these kick-ups right here, that these front ones aim air at their front brakes to help cool the brakes. The rear kick-ups aim air at the tunnel where the drive shaft and the exhaust pipes are to help keep the underside of the car cool. And then we have a small feature here. This is an access panel to have access for serviceability for your oil changes.
So I see that there is a pretty unique integration of carbon fiber composite in the Shelby. Why don't you tell me about that?
So early on in the program, in the first stages of aerodynamic development, we talk about the global shape of the car. We want the car to be as small to the air as possible. One of the things we did is we lowered the front end of the car down to create extra downforce, reduce the drag. The part that really helps us do this is this carbon fiber, what we call GOR, grill opening reinforcement. This structure holds up the front end of the fascia, the splitter, and all the sealing to the radiator and the condenser. Since we had the opportunity to bring the hood down, we thought to make it lighter using carbon fiber as opposed to steel or aluminum. So taking the weight out of the car at the front is equally important for vehicle dynamics as much as making downforce with aerodynamics. Taking that weight out of the front helps shift the weight balance to the rear and make the car better at the track. Taking that weight out of the front here, also we looked at other parts to take weight out of, one being the front bumper beam. Traditionally, front bumper beams are made out of steel. We've engineered this one out of aluminum. Meets all of our crash safety standards that steel would, but is significantly lighter by being made out of aluminum. And again, at the front of the car, every pound you take out of the front is greater than 1 pound you're taking off the front wheels and shifting towards the rear of the vehicle.
Okay, so you are one of the lucky ones that has actually taken this out on the track. So what does everything that we've been talking about, what does that actually feel like?
The car feels like a scalpel on the road. When you're going through a turn, it's planted. And that's where the aerodynamics really help us at those high-speed turns. The chassis and the vehicle dynamics teams did a great job to make the suspension tight and make the suspension rotate through the turns at low speeds. And then our job on the aero side is to help them go faster through the turns at high speeds. So what we have here is the spoiler for the R, and you'll notice some differences on the R spoiler. It's a wing, it's an actual airfoil versus the track pack being a spoiler. The track pack has a smaller splitter in the front and has a spoiler, and that spoiler is balanced out for the front downforce it makes. For the R car, with the larger splitter in the front creating more downforce, we needed a more aggressive rear spoiler, and we had to go to an airfoil where it's actually like an upside down airplane wing. So instead of trying to come off the ground, we're trying to bring it down into the ground. So that creates a good balance and a bias, so at speed, the back end just sticks through the turns.
Okay, so John, we've talked about quite a bit today. So collectively, what does that all mean for the Shelby GT350 customer?
We looked at the components on this vehicle, the tires, the wheels, the chassis, the engine. Those turn into systems and the aerodynamics, of course. All those components and systems create one of the fastest production road course Mustangs in history.
A big thanks to these very talented Ford Performance engineers. And thank you for joining us here at the Ford Performance Dearborn Development Center. I'm sure you'll agree that what these engineers have done to make this new Shelby GT350 a very special car, well, it's nothing short of amazing. I think Carroll Shelby would be very proud. Thanks again for joining us.